Welcome to the how-to for the double displacement or exchange or metathesis reactions. In these, we're really just swapping the ions in solution. And so the easiest way to think about it is if we have a reaction where AX plus BY is going to produce AY plus BX. But let's say that we have two ionic compounds, so AX and BY, and we want to predict the products of that reaction. In order to do that, all we really have to do is switch out the anions and the cations. So we take cation number 1 and combine it with anion number 2. And we take cation number 2 and combine it with anion number 1. And that ends up giving us AY plus BX, which are the two products of our reactions. So in another example where we have silver nitrate, which is reacting with potassium chloride, and we want to predict the products of that reaction, again, all we're going to do is take the inside and outside. So we take cation number 1 and combine it with anion number 2. And when we do that, we see that we get Ag plus Cl minus, which gives us AgCl as one of the products. Secondly, we would take cation number 2 and combine it with anion number 1, which is potassium ion, which is K plus, and we have NO3 minus, and when these combine, we get KNO3 is our other product of that reaction. And so we can really go through the different steps in order to write and balance a metathesis reaction. So first, use those chemical formulas, of the reactants to determine which ions are present. Write out the chemical formulas of the products by just combining the cation from one reactant with the anion of the other. Third is where we're going to now, which is we can check the water solubilities of those products to determine if a precipitation reaction has been formed. Fourth, we can balance that equation. A precipitation reaction is one type of a double displacement exchange or metathesis reaction, and it just means that one mixes ions that form compounds that are insoluble, a precipitate is formed. It is a precipitation reaction. And so in this case, we have lead nitrate, which was combined with potassium iodide, and the two products from this reaction, again, when we use cation number 1 and anion number 2, and we combine cation number 2 with anion number 1, we get the two products of lead iodide and potassium nitrate. Well, in this case, we see lead iodide is a solid. It precipitated out. We can also see that up here where when we mix the two solutions together, we get this yellow precipitate that's forming, and it sinks to the bottom. It is a solid. It precipitated out. A precipitation reaction occurs when pairs of oppositely charged ions attract each other so strongly that they form an insoluble ionic solid. So how do we determine what's actually going to precipitate in a precipitation reaction? Well, the way that we do that is we use the solubility rules. These solubility rules are listed in two different formats. One format is up here at the top, which is kind of just a list, of different rules. Alternatively, you could just use this table, which I would provide you on the exam, and in this, we basically think about what are the solubility guidelines. So we say, okay, well, these are the soluble ionic compounds, which means any compounds containing nitrate, acetate, chloride, bromide, iodide, or sulfate are going to form soluble ionic compounds, unless there are important exceptions. So you can see in some of these we have exceptions with silver ion, mercury ions, or lead ions. The bottom is the insoluble ionic compounds, and again, we can do the same thing. This concludes how to for the double displacement reactions.